Homework 2.8, Distance, Midpoint and Circles, Video 1. This homework is due Friday, May 22nd, 2020 at 11:59 p.m. And I feel I should also inform you that this homework is the last homework assignment that will be covered on Test 2. Test 2 will be made available Wednesday, May 20th at noon, and it will also be due at 11:59 p.m. on Friday, May 22nd. Okay, so in this section, as the name implies, we're going to talk about distance, midpoint, and circles. Two of the three of which are really easy, and the third one is easy, but it has a pretty annoying cousin. So we're going to start with the distance formula. In a moment, we're going to answer the question, let's find the distance between the points 2, 3 and the points 10, -1. Actually, I think we're going to start with that and then use our results to transform it into a formula to calculate distance in general. Now, how do you find the distance between things? Well, first let's sketch this. 2, 3 and 10, -1. So I don't really need any room for negative x's. So we can have the y-axis pretty far to the left. And my y values only go between -1 and 3, so I don't need much room to go up or down either. I just need to be able to go over 10. So down 1, up 1, 2, 3 is all I'm going to need. And I have to be able to go over 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. All right, so let's plot these points and see if we can come up with a plan of attack. 2, 3 is about here. And 10, -1 is over here and down here. And we want to find that distance. You know, I've got a straight edge, I might as well use it. It's more than a straight edge, it's a ruler. And a right angle. Okay. So the question is, how long is that line segment if this is 1 unit of measurement? Naturally, this is not drawn to scale, I just freehanded it. Well, how could we figure it out? Could we take a ruler, measure, look at that paper, measure how long one of these is, and then measure that and divide? And we could in theory if everything was drawn perfectly, but we need a way that calculates, not just measures. Could we rotate this? No, we can't do that. What could we do? Well, first I realized I drew that point a little bit too low, but it's too late to go back now. One thing we could do is take advantage of something that most people can recite. The Pythagorean Theorem. Do you know it? Ask a person on the street and they might go, oh yeah, a squared plus b squared equals c squared. But if you ask them what does it mean, they'll just say, I don't know, it's just a squared plus b squared equals c squared. The Pythagorean Theorem is actually a statement about the relationships between the two legs of a right triangle and the longest side, which a lot of people remember is called the hypotenuse for some reason. I don't know why they remember that, I never use that word. But I'm going to draw a right triangle by going vertically from the first point until I get even with the second point, and then going across to it. Again, please forgive the scale, it's not drawn to scale. Ooh, that was bad, I totally missed that point. Hate it when I miss the point. That was meant to be a dad joke, I'm not sure if it was worth a cheap laugh or not. All right, so we have this right triangle. And if I can figure out how long each side is, then I can do the Pythagorean Theorem and figure out the other side, which is what I'm looking for, the distance. Wait a second. Does this not look like the exact setup for slope, rise over run? It kind of does. Because when we go from one point to another, we think of it in terms of rise and run, and we're looking for the distance. So if I do the Pythagorean Theorem right now on this picture, I can say that the square of the distance is equal to the square of the run. Let's do the run first. Doesn't really matter. Plus the square of the rise. Well, don't we know how to calculate rise and run? Wasn't run just the difference of the x's, second x minus the first x? So 10 minus 2 is 8, that's how far that runs. And to calculate the rise, wasn't that just the difference in the y's, the second y minus the first y? Negative 1 minus 3, which is equal to negative 4. I know the run, I know the rise, now I can Pythagorize. I just made up that. It was lame, I know. But anyway, we don't know the square of the distance yet, but we're going to find it. The run was 8, so we can say 8 squared. The rise is negative 4, and it may seem funny to label the side of the triangle as a negative, but in the context of slope that makes sense because the negative indicates the direction we're going. Well, let's finish the math. 8 squared is 64. Negative 4 squared is 16. And so the square of the distance is 80. Well, that's a quadratic equation. We know how to solve that. We can square root both sides. And normally I would say, and don't forget the plus minus, but distance is always positive. So when we square root this, we can just say the square root of 80. Now, if this were a homework question, it would not accept this answer as is, because answers like the square root of 80 are expected to be simplified. If it were the square root of 81, we would just call it 9. But we can break off something and square root it. I know this is at least divisible by 4, and 4 is square rootable. So 4 goes into 80 20 times, and the square root of 4 is 2. But even that's not good enough, because we've broken down a 20 before. We can break off another 4, leaving behind a 5. The square root of 4 is 2. I don't know the square root of 5, and I have a 2 from the first 4 that I broke off. These 2's multiply to give 4, and so we can say that the square root, the distance between those 2 points is 4 times the square root of 5. Now in the homework it would want an answer like this, and that would be called the exact answer. But in some of them it will also ask you for a decimal approximation, which means put it in a calculator and round it off. I believe it'll say round it off to 3 decimal places. Looking for a calculator that has a square root button. Here's one. Now we could do 4 times the square root of 5, or we could just go back and do the square root of 80. I'll do the square root of 80. And at 3 decimal places we get 8.944, which really doesn't surprise me. It should have been close to 9 because this is close to 81. So that's discovering the distance formula, but we don't really have a distance formula yet. We've just done one problem. So how can we take this specific example and make a formula out of it? That way, when you do your problems in your homework, problems 1, 2, 3, and 4, you can just get out the formula. Well, let's see if we can replicate what we did there over here. The strategy was to set up the Pythagorean Theorem, where the square of the distance was the square of the run plus the square of the rise. But how do you calculate the run? Subtract the x's. x2 minus x1. And how do you calculate the rise? Subtract the y's. y2 minus y1. If we square root both sides to get the d by itself, then we would drop a gigantic square root over all of this. And if you're thinking the squares cancel the square roots, stop. You cannot distribute a square root across a plus. This is as good as it gets. So what you see here is the distance formula. It's the square root of the sum of the squares of the differences of the x-coordinates and the y-coordinates. And we would have gotten the exact same answer had we substituted x1, y1, x2, and y2 into that formula. So when you do the distance formula, you actually have a choice. Or when you do a distance problem, you have a choice. You can use this formula, which is just the Pythagorean Theorem in disguise, or you can draw the picture and reinvent what happened here. Draw the triangle, measure the run and the rise, set up the Pythagorean Theorem, and then square it at the end. Both will give you the same results. The distance formula is more efficient, otherwise you're reinventing the process every single time.